Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to demonstrate how to read HDF file data using Python. So what that means is I'm going to identify a .hdf file within the project directory and then use a Python script to extract that data. All right, so let's go ahead and get started. I already have a fully developed and ran a simulation here. It's a 2D simulation that involves a sediment flow. So there's lots of data over here. I'm in my HEC RAS mapper window. I have the original data files, the results files for velocity, water surface elevation, and depth. But then I've also added a few more of my own, such as bed change, total load concentration, and bed elevation. This is the result of my previous lesson. In case you're curious, that's lesson 93, where I talk about the results of this particular model. And with each plan, there will be a .hdf file that includes the results. So if I open up my project directory here in my Windows Explorer, there should be a .hdf file, which is this one right here. I actually have two plans. So this is the first plan. This is the second plan. I'm going to go ahead and look at the results from this second plan. This is the HDF file. So if I go ahead and right click and open up in a text editor, you're going to notice that you cannot really read the HDF file that way. And that's not a problem. We can use a Python script to export that data into a format that we can use. All right, before I do that, let me just kind of do a quick demonstration and a comparison between exporting data manually, because there's nothing wrong with using RAS Mapper and exporting data if that's the most efficient way for you based on the data you need. But what I have over here selected is the bed elevation layer. There are other layers that I could be adding in and analyzing, and then we're probably used to seeing that, yeah, water depth or like the terrain layer. Oops, let me toggle that off. Yeah, so there's the terrain layer that you're probably used to, but I'm going to focus in on this bed elevation layer. And say, for instance, I want to zoom in on a particular cell here in the river. 15.69 is the current bed elevation. This is at the beginning of the simulation. And then during the simulation, it may change a little bit and hence change colors. That's fine. 15.7. I'm going to go right click, plot time series properties, cell bed elevation. And you can see that the values here increase from about 15.68 up to 15.69. So not a huge change, but it's only a 3-day simulation. If I click on table, I can get the data. This is a 1 hour time step. So over 3 days, that's 72 hours, or there's actually 73 records here because it's also the end of the simulation as well. And then if I wanted to copy the data with header, or I could just Control C to copy the data without the header, and then come over here to my project directory. And then how about we just create an Excel file? I'll call this data manual.xls. So it's data that I'm extracting manually. Then I'm going to open up that file. And then I'm going to paste it in, Control V. So here is my data. What we have is 73 records. I think it's 73. Yep. This represents that bed elevation of that one cell in the grid that we exported from RAS Mapper. So that's perhaps all you need, in which case doing a manual edit is fine. You don't need to write a script and extract data from the HDF file. But say, for instance, you had hundreds or thousands of cells and you don't want to perform this task hundreds and thousands of times. That's where the script comes in, and it's kind of up to the modeler to decide at what point does it make sense to write a script to do this data extraction task, and at what point can I just do it manually like you saw me do here. Okay, so let's pretend we want to extract this data for every cell, not just one, and we'll put that into an Excel file. So instead of data manual, I'll go ahead and close that, save. I'm going to create another Excel file here, new Excel. I'm going to call this data script. So this is sort of the landing spot, the final destination for the same bed elevation data from our model, but it's going to be something we write into via a script. All right, so let's go ahead and get started with that. The remainder of this lesson is going to be a little bit different. I'm going to be writing a script and pasting in some code and explaining it. So we're going to depart from HEC RAS for the majority of the remainder of this lesson, but just stick with me. All right, so what I'm going to start by doing is opening up VS Code. This is the IDE I use for scripting, at least for Python and this kind of thing. Navigate to your project over here. You can go up to File, Open Folder. That's what you want. Navigate to your folder. I'm already where I want to be, so that's good. Next, I want to create a script file. Now, I could do some of these tasks out in Windows Explorer, but I'll just kind of demonstrate how it works within this IDE. So to create a file, I'll just click on the new file button. I'm going to call it script.py and then click enter. The file is open. If I want to open the terminal down below, I can just Control J, and now I have access to run the script and type other commands. I can also access the terminal by going up to View and then Terminal. That's how to toggle it on and toggle it off. So either that or Control J. Now, the first thing I want to do is to install my HDF5 Python library. So if you don't already have that, just go ahead and type that in pip install h5py down here in the terminal, hit enter. I've already done that, but I'll just show you what it looks like if it's already installed. So I'll hit enter. You may have to wait a moment. You may see a loading screen or a progress bar, but once you get the prompt back, like I have right here, it's already loaded in, which is what it says for me. Right here, requirements are already satisfied, and it includes the NumPy library. All right, with different file numbers, and of course it's bugging me to install the new version of pip. No thanks. All right, so we're going to start off by writing code, and I'm going to paste things in just out of the interest of time. Here is the first block of code. The first thing I'm doing is importing that library that we installed, and I'm running this locally. I'm not running it on some external server or the web page or anything. It's just on my machine. What I'm doing in this block of code, lines 3 through 5, is I'm calling this function explore HDF5, and I'm sending it my file handler F, which is reading from the HDF file of my results. So this is the HDF file that we saw. That's this file right here. This is a relative path, but if you needed to reference a .hdf file in a different directory, you'd have to change this accordingly. I am reading it. Okay. So this explore HDF needs to still be included, and I'm going to put that in right up here. This is a recursive function that just searches through the structure of the HDF5 file and returns all the groups, and also indents the grouping so you can kind of see the structure of it as well. I'm not going to talk about all this too much. I'm just going to go ahead and run it and show you what it does. So down here in the terminal, I'm going to clear that and then just type in Python and then script.py. Obviously, you need Python installed in your machine as well. It's probably going to be Python 3. And of course, the environmental variable needs to be set for Python. So that should work. I'll click enter and let's see here. Okay, that was just my mistake. I misspelled script.py. So the file that I'm writing up here is called script. That's a bonehead move by me. So I'm just going to go, you can arrow up to visit previous commands. So that's easy. And then, of course, I want to run the correct command, script.py, and boom. All right, boom. So what we just saw was, let me scroll up to the top there. Here was the command, and then here is the script that basically says HDF5 file structure, and then here I'm printing out the actual file structure. So HDF files are basically data sets that are nested inside of groups, and groups can be nested inside of groups and so on and so forth, hence the recursive requirement there for that function. So one of the top level groups is event condition, and then it has child groups called sediment and unsteady. And then the next top level group is called geometry. It has children groups called 2D flow area break lines, 2D flow areas, and so on and so forth. What you're seeing here is every single group and data set in that HDF file. And that's why there's just so much here. It may be a little bit too much to look at in one view. So to rectify that, I'm going to only print out the groups in the current directory that you send a function. That way it'll behave a little bit more like Windows Explorer. So we're only seeing the files in this directory. And if I click on a different directory, you're only seeing the files in this directory and so on. You can only look at the groups in the directory that you're in. So I'm going to come up here. I'm just going to add a new function here. This is going to be a function called list groups. Now, what I'm doing here and just finding the data, this is not something you're going to have to do every time. Once you know exactly where in the HDF file that your bed elevation is located, you don't need to do all these things. So this is just a way of kind of exploring the HDF file first, and then after that, we're going to extract the data, and then that would be more of a routine task. This right here, what I'm doing, finding the data I need within the file, it's more of a one-time task. Okay, so what it's going to do is print out a list of groups based on the group that I send this function, list groups. So what I'm going to do is comment out these two lines here, still within this file block. What I'm going to do here is paste in This code right here is going to say group is F. That represents the file. So I just want the top level groups this first time around. I'll go ahead and hit save, and then I'm going to come down here and run it. So just call the script once again. All right. So what I have here is the list of top level groups. It's event conditions, geometry. We saw those two. Further down, what we didn't see was plan data, results, and sediment. So say for instance, I want to look at results. I want to explore we want to click into the results window or look into the results group and see what other result groups are in that group. That's not a problem. I'm just going to come up here and then change this to include results and then save and then rerun that. All right. So within results, we have summary group and unsteady group. All right, so let's go ahead and check out the unsteady group. I'm just going to append another group name to this line 23 here, unsteady, and then click save, and then come back down here to my console, run the script again. All right, so within results unsteady, we have the following three groups: geometry info, output, and summary. All right, so to save us some time, I'm just going to go ahead and paste in the final group string that leads us to where we want to be. It's within results, unsteady, output, output block, sediment bed, unsteady time series, 2D flow areas, and then the name of the 2D flow area, which happens to be 2D flow area. All right, so if I go ahead and search the groups within this nested group, let me go ahead and clear Python script. And here we have no groups because my function is actually returning just the groups, not the data sets. Now is where I have data sets within this group. If I want to print out the data sets, I'm going to just include a new function. Here's my print groups function, and then here is my print datasets function. What it is I'm sending it to HDF5 group, but instead of printing out the group, I'm printing the data set. So let's go ahead and print that data set. So let's come down here, and then instead of listing groups, I'm going to pound to single line comment and then paste in the list data sets using that group. Okay, so save, and then let's run it. So here are the data sets that are in that group. We have cell bed change, cell bed elevation. That's the one we want. Cell initial bed elevation, log sediment bed, and so on. So I'm not going to read all of these, but like I mentioned, the one we want here is cell bed elevation. We want to extract the data from that data set. Okay, so I'm going to go ahead and paste in another block of code that does exactly that. We're going to print data in the data set. So here is the dataset path. It starts with results and it ends with not the last group, but the last group slash the dataset name. That dataset is read into the path and then parsed by the colon character. And we're just going to print that data from the dataset, the cell bed elevation dataset, right here into the console. So for that matter, I'm going to go ahead and give myself a little bit more room and then save the file. And let's go ahead and clear and then again, run the script. All right, so here is the results. Here's the list of the data sets. Again, I didn't comment that out, so I can do that right up here. That's fine, save. And then down below here is the data itself. Now, as you can see, it's truncated data because we just don't have enough room in the terminal window to actually print it all out. That's fine. And it looks like it's taking elevation to the nearest 10,000th of a foot. That's a little overkill. Well, even more in this case. But what we have here is a matrix of data. It's just two-dimensional where we have rows and columns, where each row represents a different time series, and then each column or attribute would represent the cell. In fact, you can get some of that data as well. If I'm just going to copy this, cell bed elevation, Control C. This is what I want to search for when we return the results from that original recursive function that basically listed out all of the groups and data sets in the same view. So I'm going to go ahead and scroll up and toggle that on once again to print the Explore HDF5. That I should probably have labeled that something like print out all groups and data sets. So I'm going to go ahead and save that. Let's go ahead and run it now. Check that out. Now I'm going to do is Control F and then find the cell bed elevation, and I should have that somewhere else as well. Right, so here is the cell bed elevation, and it's nested within 2D flow area, which is nested within 2D flow areas, which is nested within unsteady time series. So these are the different groups. And then this data set right here for cell bed elevation, it has the shape of 73, 901. So 73 rows, that's the 73 different time steps or hours in the 3-day simulation plus the 1. and then it is using a data type for 32-bit signed floating point number. So that is what we're going to be extracting next. Back to the code here. I'm going to comment out the recursive function that prints everything. And I'm actually going to comment this out as well, the individual values that were truncated anyway. Next, what I want to do is include a library called pandas. If you don't already have pandas installed, you can also just pip install it. Come down here to the terminal, and then we clear the search. And then what you're going to do is just type in pip. Okay, so I pasted it and ran it at the same time. You want to run this pip install pandas and then also open PyXL. That's going to be able to interact with Microsoft Excel. I already have that loaded in. That's why you're seeing it says that it's already loaded. And then after that, I want to import the pandas. So I'll come up to the top of the code, import pandas. And then to actually make that conversion from the data set in the HDF file into Excel, we're going to go ahead and convert pandas to a data frame. That's just this typical way of using the pandas data library. And then I need to write that data to Excel, and I need to specify the path to my Excel file. So let's go ahead and grab that. This is the Excel file that we created earlier in the lesson. We have the manual version right here, and then here is the data script file. So I'm going to right click, grab that path, copy as path, minimize, and then I want to paste that in right here. So Control V, and I have an extra set of quotes, so that's good. Here's the file, datascript.xls. Everything before that is just the path on my personal computer, so yours is going to be something different if you choose to do this. And then this last line here is actually going to write the file. So let's go ahead and save it. Let's do a before and after on the Excel file. I'm going to open up that data script file right now. It's 7 kilobytes. There's nothing here basically. Okay, so I'll go ahead and close that. Now let's go ahead and run this script locally. I'm going to come down here, clear, and then run the script. Give it a moment. Okay, so it just returned my cursor after just a few seconds. And let's go ahead and see if that worked. All right, that looked like it worked. We now have a file. Our Excel file is 736 kilobytes. I'm going to go ahead and open that up. And it looks like we have data. All right, so let me scroll down here. And we have 73 rows of data. So what this tells me is that each row is an hour or a time step, and then each column is a cell. So so we should have 900 and something cells. Okay, so the column is AHQ, not helpful. I'm going to go ahead and toggle on the R1C1 options, and then formulas, click on R1C1 reference style. Okay. And sure enough, 901. See, the columns are now labeled with numbers because that's a little bit more intuitive, especially if you're trying to count. And we have the 901 different cells from that 2D flow area are printed out here in each column. All right, so if we wanted to track the bed elevation from that sediment results layer in Excel, we would go ahead and find the individual cell, say it's cell number 6, and then we would see how it changes over time. Or maybe it's, I don't know, cell number 448, and we can see how that increases over time. Anyway, that is where I'm going to end it. What we did was use a Python script to extract the results from a 2D flow simulation run that involves sediment from the HDF file, and we got it imported into an Excel file for further manipulation.